All right, Brandon Clayton here, the Algebra Guy, and as you can see on your screen, we're talking about simplifying expressions using the laws of exponents. Particularly for this lesson, we're talking about using the product and power rule, which we'll get into here in just a second. What's the TEK that's being covered? 11B, simplified numeric and algebraic expression using the laws of exponents. So let's jump right into it. And here are the particulars that we're going to discuss. Like I mentioned, product property, power property, and product to a power property of exponents. So it'll make sense as we get through it. And I put this here because I want to show you and remind you, if you already knew that all these properties are given to you on your reference sheet. So a lot of times students look over this, but look, when they give you all the properties, and we'll discuss these, but when they give you all these properties, the ones we're going to discuss is here for this time, and then we'll get into the others on the next lesson. But when they give you all these properties, please use them because they're right in front of you. You don't have to memorize any of those. All right, so let's get into it. All right, so first of all, simplifying expressions with exponents. All right, just a reminder, remember that an exponent indicates repeated multiplication of the same quantity. So for instance, if you have 2 to the 4th, this is really just saying 2 4 times being multiplied. So this format is known as exponential notation. The format here is a some base to the exponent m. So you can use any letter there, but they use a to m, where a is some variable or number, but to some power. What all that's saying is that you're going to take that base times that many times that power. So if it's m, that means it's m times. But I think you get that idea. In the expression a to the m, this exponent tells us how many times we should use the base a as a factor. Here's an example. So 7 to the 3rd is the same thing as 7 times 7 times 7. So those are the 3 factors. Why? Because you have an exponent of 3 and you're taking that base 3 times. Same thing with negative 8 to the 5th. Even though it's a negative or in a different number 5, don't let that confuse you. You're still going to do the same thing. Take that base that many times to the exponent given. So 5 times in that case. All right, so what about this one? Before we begin working with a variable expression, let's simplify a few expressions involving only numbers, and then we're going to get to some of the ones that's expressions with variables. All right, so first let's look at this one. So 5 to the 3rd, remember that's just 5 times 5 times 5. Right, so 5 times 5 times 5, and you can leave it that way, but we can simplify 125. 9 to the first power is just 9. No more you can do. There's only one time. 7/8 squared. Now that may seem a little tricky. One thing you could do is 7/8 times 7/8. But we also learned later that you can just square the top. 7 times 7 is 49, and square the bottom. 8 times 8 is 64. But either way, you need to know that we're just taking this fraction and multiplying it twice because it says to square it. Same thing here is 0.74 times 0.74. So it's that simple. And we could do the math on that, but right now that's not important. Knowing how to understand this is the most important piece now. Negative 3 to the 4th power, well, that's negative 3 times negative 3 times negative 3 times negative 3. Now, negatives are interesting, and they're important to understand that obviously when you multiply two negatives together, you're going to get a positive number. But if you have 3 negatives, it's going to change it to negative because it's going to be negative times negative is a positive. Positive times another negative is going to make it negative. So in other words, every time you have an odd exponent, it's going to be a negative value. Here, negative 3 to the 4th. Now, this is a little bit different, although they look alike, right? The only difference here is parentheses. The difference here is that you're going to take 3 to the 4th, 3 times 3 times 3 times 3, and whatever answer you get, in this case, I think it's 81. 3 times 3 is 9, 27, 81. You're going to get 81, and then you're going to multiply the negative on the end because it's not included in the parentheses. In this one, we got to take the whole entity, which is negative 3, negative 3, negative 3, negative 3. And here we put it on the end. So keep that in mind, especially when you're putting it in your calculator, because the calculator will handle it just like that too. And you may be wondering, why is the calculator getting a different answer than I am? And that's the reason why. All right, let's go to our next lesson here. Simplify expressions using the product property of exponents. So what is the product property of exponents? All right, the product property is just as it sounds. You have a product of two things. Remember, product means the result you get from multiplying two terms. So what is this going to equal? X squared times x cubed. What would you assume? So x squared times x cubed. Well, let's look at it. So x squared times x cubed is the same thing as writing x times x times x times x times x. Here you have two factors and three factors. In total, you're really just, if you smushed all these together, don't you just have 5 factors? So we could have written it x to the 2 plus 3, because we're really just talking about a total of 5 of these. We have 2 here and 3 there. So really just x to the 5th. So the base stayed the same and we added the exponent. This leads to the product property for exponents. Now, if you wanted to look at it formally with variables, here's the idea. Here's what the rule looks like. Some base to an exponent times that same base to an exponent is equal that base, and you add those exponents together, because that's what we really ended up doing. And don't fret if you forget the rule, because again, it's on your star reference sheet. And secondly, you can deduce the rule yourself by just saying, what is x squared? Well, that's just x times x. What is x cubed? That's x times x times x. Well, all of these are just being added together, right? These exponents are going to be added together because it's just x to the 5th. So you can kind of do some common sense, or just look back to your reference sheet. Here's another example. 2 squared times 2 cubed is the same thing as 4 times 8, which is 32. Or you could have just added the exponents here. 2 plus 3 is 5. 2 to the 5 is 32. So notice they're giving you the same exact answer. All right, let's practice a few of them here. X to the 5th times x to the 7th. What is that going to give us? Well, we know we have the same base. So what can we do with the exponents? Well, we can just add those together. So 5 plus 7 gives us x to the 12. What about this one? This is same base again. What can we do with the exponents? Add them together. But don't forget, as some students do, there's a 1 right there. So I need to add that one as well. So this becomes b to the what? 5th. And 2 to the 7th, 2 to the 9th, again, same exponent. Yes, you could work out 2 to the 7th, and you could work out 2 to the 9th, and you can multiply those two. But how much nicer is it when you know the rule that you can just add these two together and get 2 to the 16 and do one problem? Now, again, the answer is not important to us now, especially as we get into variables and expressions. So I'm not interested in finding what that long answer is, but understanding how to apply these exponent rules. All right, again, same base, so we can add the exponents when they're being multiplied. So that gives us y to the, what is that, 40th? And again, all the same base. What if you have 3 terms? What do? So we're still going to say x to the, and we're going to add those exponents, 3, 4, and 2. So this is 7 plus 2 is 9, x to the 9th. All right, let's simplify expressions now using the power property of exponents. So let's look at an exponential expression that contains a power raised to a power. So what can we discover about the rule associated with this? What if you have x squared cubed? Or another way to read that, x squared to the 3rd power. Well, that's the same thing as saying x squared times x squared times x squared. So we know how to work this one, don't we? Because they have the same base. So what do we do with the exponents? Well, we add them. So another thing we could have also done, because it's a power to a power, is multiply them. 2 times 3 would have given us 6. 2, 2, and 2 gives us 6. And so we got x to the 6. So there's a rule here that if you have an exponent raised to a power, all you need to do is multiply these two, and it'll simplify it instead of having to write all the expressions, all the terms out, as you see over there. So here's an example of how it would look. 5 squared to the 3rd power can be completed by saying 5 squared is 25. 25 cubed is 15,625. Or you could have just said 5 squared is the same. 5 squared cubed is the same thing as 2 times 3, which is going to give me a 6, 5 to the 6th power. Working it both ways is the same answer, but it's nice that you can go straight from here to just multiplying these out and do one problem instead of, I think this is like an extra step, maybe 2. All right, let's practice that. X to the 5 to the 7th power. So what do we do with these? Well, it's the same thing as saying x to the 5th, x to the 5th times x to the 5th times x to the 5th, and so on. So we're going to end up multiplying these two. 5 times 7 is 35. And what about this one here? So you could say figure out what 3 to the 6 is, then take that answer to the 8th power, or we could just multiply these two, which is what I'm going to do. 3 to the 48th power. My goodness, I can't imagine how big that number is, and it doesn't matter for us now anyway. So simplify expression using a product to a power property. We will now look at an expression containing a product that's raised to a power. So what about this expression? Notice that it's not just a variable in there. Now, how are we going to handle this? Well, as you can imagine, it's the same thing as saying 2x times 2x times 2x. Well, what is 2x times 2x times 2x? Well, we can kind of figure that out, can't we? That's just going to be 2 times 2 times 2 and x times x times x. In other words, 2 cubed times x cubed. So we're just rewriting it here. So what are we concluding? It's the same thing as just saying 2 cubed times x cubed when you have this piece here. The rule is this. Whenever you have AB raised to the m power, it's the same thing as taking that exponent and applying it to each term inside that parentheses. So notice that the A gets the m and the B gets the m. Oftentimes, the mistake students will make is only applying that exponent to the last term because it's so close to there. But remember, this parentheses is suggesting that this exponent is applied to every single piece inside, every single factor inside of that parentheses, or every single term. So here's an example. 2 to the 3rd, 2 times 3 to the square, that is squared. You can say 2 times 3 is 6 and then square that. Or another way you can write it is have this square be applied to the 2 and to the 3 as you see here. So now we get 4 times 9, which is 36. Both ways are right, but this is going to be the way that tends to be easier as we take away the numbers. So that's what we're going to focus on. All right, let's practice a couple. Pause it and see if you can work this one by yourself. So I'm going to rewrite this negative 11 squared and times x squared. And that's the first step I would do because I know that this 2 gets applied to both of these factors here. So negative 11 squared is going to give me a positive 121. Let me undo 121. And this is just going to be x squared. Why is it positive? Because this whole thing, this negative 11, I should have put in parentheses, is being squared. So not just the 11, not then a negative, but this whole negative 11 is being squared. All right, what about this one here? So this is the same as 3 to the 3rd times x to the 3rd times y to the 3rd. Well, 3 to the 3rd is 3 times 3 is 9. 9 times 3 is 27. And I have x cubed and then y cubed. All right, let's apply several different properties. We now have 3 properties we've been using. Summarizing them right here. So as you can see down here, let's start applying those. And I want you to pause it as we go through these examples and see if you're getting the same answer that I'm getting. All right, so our first one is here. Again, pause it and I will see if you can work these 4 before I work them. See if we come up with the same thing. All right, so remember the rule for powers raised to a power. We can just multiply these two. So this gives me x to the 12th power. And this is going to be multiplied by x to the 5 times 4, x to the 20th power. And now I have another rule I can apply, the product rule that says I can add the exponents whenever my bases are the same. So x and x are the same bases. Now I'm going to add my exponents. 20 plus 12 is 32. And there it is. All right, let's try this one. This one I got to remember that this negative 7 is going to be squared. Everything inside of here, every factor inside of here is going to be squared. So negative 7 is going to be squared. my x cubed is going to be multiplied by that 2. And my y to the 4th is going to be multiplied by this 2. So everything's going to feel the effect of this square. So don't forget that, every single piece. Now we're going to simplify by doing -7 squared, which is 49. X 3 times 2 is x to the 6th, and y to the 8th. All right, same thing for this next one. Is 6 is going to be squared, n is going to be squared, and it's going to be multiplied by 4n cubed. Now notice I didn't put the cube on the 4. Why not? Because this cube, this 3, is not on the outside of the parentheses, forcing the 4 and n to be cubed. It's only the n that's being cubed here, so be careful of that. Now at this point, what I want to do is multiply my 6 squared. Actually, I better go ahead and simplify this a little bit first. 36 n squared times 4n cubed. So I also notice that I can multiply a little bit more here, because 36 times 4 can multiply together. And what is that going to give me? Let me do the math on that real quick. So 36 times 4, 4, 2, 12, 144. So 144 when I multiply those two numbers, and n squared times n cubed. So I am still multiplying those, although they're not right next to each other, they're still being multiplied. So I apply the same rule, the product rule, that tells me to add the exponents. Adding the exponents here gives me n to the 5th. All right, one last one here. So that looks like a pretty big problem, but what do? Step by step, one piece at a time. 3 is going to be to the 4th power. And then p squared to the 4th power. P squared to the 4th power, which is going to be multiplied by 4 because of the power rule. Q is going to be raised to the 4th power. And this is all going to be multiplied by 2 raised to the 3rd power. This is multiplied by 2 raised to this 3rd power. P raised to that 3rd power, and Q squared raised to that 3rd power. So let's go through and simplify everything. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And P, this becomes P to the 8th, and Q to the 4th. 2 to the 3rd is 8. So this is times 8. P cubed, and Q to the 6th. So that's a lot to write down. But again, one piece at a time is not difficult at all. Now I'm going to multiply my numbers together, 81 times 8. And I'm just going to use my calculator for that. What is 81 times 8? Let's see if I can find my calculator. So let's put it over here. Let's do 81 times 8 and 648. So what we're looking at here. So 648. And we have P, and we have P8 to the 8th power and times P to the 3rd power. Remember, because all this is being multiplied together, so I can add these exponents. So I'm going to cross these out to make sure I don't get confused with what I've already done. Q to the 4th times Q to the 6th becomes Q to the 10th power. And there we are. Beautiful. All right, since a monomial is an algebraic expression, we can use the properties for simplifying expressions with exponents to multiply monomials. So you're going to do the same thing here. If you can pause it, see if you can work these two, or at least start with this first one before I do. All right, so I'm going to go ahead and work it here. 4 times -5. So I'm going to start with multiplying my numbers. This is saying 4 times -5 is -20. So I took care of my 4 and 5. Now I have x squared times x cubed. Now, why am I multiplying? Because remember, there's no, when you have parentheses times the parentheses, there's an understood multiplication here. So I understand that everything's being multiplied. All right, so x squared times x cubed, I can add the 2 and 3 to make that x to the 5th. See how much nicer that looks? Look at that compared to that. All right, so what about this one? 3/4 times 12. I'm going to multiply all my numbers first. 3/4 times 12. What is 3/4 times 12? Well, 12 divided by 4 is 3. 3 times 3 is 9. So this is going to give me 9. 9 there. So I did that part. C cubed times C is C to the 4th. Because there's a 1 there, and I added 3 and 1 together. And then D to the 1 power is in D squared is going to give me D cubed. And here we go. What does it look like on star? So let's do a couple of star problems. Now this is actually a problem that I should have saved for our next lesson because it involves division. But let's see if we can set it up so we can get it. The area of a rectangle is 54 x to the 9th y 8th square yards if the length of the rectangle is 6x cubed y to the 4th yards. Which expression represents the width? So if you think about it, they're giving us area. Well, area of a rectangle is length times width. They gave us the area and they gave us the length. So to find the width, we need to divide these two. It needs to be A divided by the length to equal my width. Now, we haven't talked about division yet, so I'm going to see if we can work this through multiplication. Again, I should have saved this for the next one, but that's okay. Well, I know that my length, let's do my length and width. I know that my length is 6x cubed y to the 4th. And I know it's being multiplied by something, so something is being multiplied here to give me 54. And x to the 9th, y to the 8th. So that's my area. So this is, in essence, length times width equals area. So I want everyone to see that. That's all we're doing. So how do I know what to get? So let's think about the numbers. I need 6 times something that's going to give me a 54. Well, what 6 times what gives me 54? Well, that must be a 9. So it can be 48 and it can be 60. Hey, it's working out pretty good with just these couple of rules. And what we already understand about length times width and area and such. So I know that it's between F and H at this point. So this is going to be a 9. This is a 9. X to the 3rd and x to the 9th. I need to multiply x to the 3rd by something to give me x to the 9th. So x to the what power would give me a 9? So I have a 3. I need to, these exponents are going to add together to give me a 9. If you remember, like basis, when you multiply, add the exponents. So what is that going to be? Well, 3 plus 6 will give me 9. So you probably were already saying it. So there's my 6. And I can already see my H is the answer because it's not a 3. Y to the 4th, I need another 4 to get to this 8. So there it is right here. Great job. All right, here's another one. The expression x to the 3rd times x to the negative 17 is equivalent to x to some number. What's the value of n? Well, they're just asking you to do the product rule. When you multiply to add the exponents. So what is that going to be? Well, negative 17. This ends up being just negative 17 plus 3, right? Because we add the exponents when our bases are the same. Only when you multiply. I want to mention that again because sometimes students may see this and get used to seeing that and think, oh yeah, we add these. But this is between addition. Only when these are being multiplied like you see here. So that's why we're going to add the exponents. So negative 17 plus 3 gives us a negative 14. So you want to write that on your answer document for that one. All right, which expression is equivalent to all of that stuff? Oh my goodness. So let's figure what this is. One piece at a time. All right, so we got set all of this 7x cubed to the squared. So each piece in here is going to be squared. So I need to do 7 squared. And this is going to be x cubed times 2 because that's going to apply there. And here I got x to the 1/2. I'm sorry, x to the 8th times 1/2. This is going to be the power rule because we can multiply these two. Now here's a side note. Anytime you have something raised to the 1/2 power, you won't have to use this a whole lot, but that's actually the same as saying the square root of that something. So the square root of x. That's on your reference sheet as well. Because there's the 1 comes from the exponent here, the 2 comes from an understood 2 here, which is saying this is a radical. Something times something gives me this value. So two things multiplied together give me that value. So that's just a little side note. So anyhow, I'm going to multiply these two, x to the, let's say 8 times 1/2. So we'll just write it out. Now we'll work it down here. 7 squared is 49. And I'm not multiplying by any other number, so I know my number is going to be 49. I'm going to look over here. Nope, not 49 and not 49. Nope, can't be that. So what about this one? X times 3 times 2, that's x to the 6th. And x times 8 times 1/2. Well, 8 times 1/2 is just half of 8, which is 4. There we go. So I see I have multiplying by like basis. So what can I do with the exponents? Good, we can add the exponents. So this is the one I'm looking for. Yay! All right, let's go to our next one. A rectangular prism has a width of x inches. Let's underline that. Then we have a width of x inches, a length of x squared times y inches, and a height of y squared inches. What is the volume? Well, if you remember, volume of a prism is length times width times height. So we're just saying what's the length times the width. This is the width times the length, x squared y, times the height. So that's really the problem we're looking to work here. Well, how do we do that? Well, remember we have like bases. When we multiply them, we can add the exponents. So there's a 1 here. So x times x squared is going to be x to the 3rd. So I did with the x's, and then we got y times y squared. There's a 1 there. It's going to be y to the 3rd. Now, what's going to mess students up? The 1. So we can forget that and just say this is a y squared and x squared, or some other things. But don't forget there's a 1 there. So here is our answer, J. All right, that does it, guys. Thank you so much for tuning in. Did we cover everything? Simplify numeric algebraic expressions using the laws of exponents. So we just focused on the product property, the power property, and the product to a power property. And you guys did a fantastic job. Again, my name is Clayton, the Algebra Guy, and I will see you next lesson.